Semester, my colleagues and I worked on addressing congestion problems that build up on exit 111 in Immokalee Road and exit 107 in Pine Ridge Road. Also, due to the growing population of Naples, we researched whether the area needed an intersection on Vanderbilt Beach Road and I-75.
Interstate 75 experiences different levels of congestion depending on the time of day, as southbound 75 heading towards Naples is seen to have a higher density of traffic, as many commuters on their way to work around the times of 7 and 9 a.m. Northbound is more congested towards Fort Myers around the times of 4 to 6 p.m., as many of those people are on their way back home. The Florida Department of Transportation ideally wants to have interchanges at least 2 miles apart from each other. Therefore, an interchange at Vanderbilt Beach Road will be a perfect fit as it is directly in the middle, as Pine Ridge Road exit 107 is to the south and Immokalee Road exit 111 is to the north of Vanderbilt Beach Road. Therefore, Vanderbilt Beach Road exit will be considered as exit 109, and it will help reduce the stress at exit 107 and exit 111, as the commuters will be able to exit at the interstate at their desired location rather than congesting those two main roads. Collier County already has plans in the works to have Vanderbilt Beach Road to be extended eastward until it connects to 16th Street to help alleviate the expected traffic volumes to be experienced in the near future, as development in eastern Collier County continues to be done around Ave Maria's location. In all design projects, it's ideal to get out into the field and take a visit to get a better understanding of the problem that is being experienced. It also provides a chance to see what you have to deal with from a design standpoint, such as what is limiting or prohibiting you from completing that specific design. When our team was able to take our field visit, we gained valuable knowledge while being able to capture some photos of the surroundings. As can be seen on the slide, the photos that were captured showed some design challenges that would need to be dealt with, such as the elevation difference of Interstate 75 and Vanderbilt Beach Road. When trying to design and build a ramp coming off at a higher elevation and bringing it down to a lower elevation could be problematic. Another design challenge that we noticed was the canal on the east side of Interstate 75. This canal would either have to be backfilled and have a box culvert installed to allow the water to flow underneath. By doing this, it will allow the construction of ramps to be placed over top of the newly created land.
For the design of the I-75 and Vanderbilt intersection, the team had many ideas going back and forth, but it was not until a Saturday when we went with Julio Ordonez from the Collier County Transportation Division that we were able to physically see the intersection for our eyes, and we were able to see possibilities and restrictions to the design. For example, in the northeast and southeast corners, there's a canal running with culverts that would have to be addressed if we were to have ramps coming off or on to I-75. And on the northwest and southwest corners, we had communities that we had to consider. But this was really made much more clear after we saw the site physically, and then we went back into the office, and this is where we were discussing with Jacobs Engineering, Bill Grammer, and Nick DeCiccio. We were able to talk with them about ideas, and then they were able to provide input as to, well, for example, if you've got a community there, you might need to put up a noise wall depending on the closeness of the community to I-75 and so forth. But initially, some of the ideas that we had were flyovers, a conventional diamond, and then a divergent diamond. The flyovers seemed practical at first, but the issue came about when you had to drop from a high elevation and get down to that same elevation as Vanderbilt Beach Road, and it was just not enough that we could say this is going to be a good idea and it's going to work. But we considered it as an alternative. We tried to go through all the pros and cons of it, but found that the slope was just going to be too steep to be able to implement the flyover. Next, we kind of were in between the conventional and divergent diamond. We wanted to go with the divergent diamond due to the success it's been having, and we wanted to implement it. We saw it as a great possibility to help the flow and help the traffic volume. However, we noticed that it may be too soon to start implementing the divergent diamond because it is mainly used at intersections with heavy volume. And due to Vanderbilt and I-75 now being quite open, we are were unsure that the convergent diamond was going to be the best implementation in there, as well as the physical surroundings, the setting, the environment. We didn't know if it was going to work, so we ended up kind of tackling the alternative, which was the conventional diamond, which is very similar, except there's a few minor differences in the way that it is approached. On the ends, users can make U-turns instead of crossing over.
With research and choosing a design out of the way, we focused on development design that will minimize the amount of area that will be needed to avoid touching areas such as the park, homes, and an existing retaining wall. As it can be seen, this is what the final product looks like. But first, let's play a video showing the idea behind these and talk numbers in a bit. This video is going to show the perspective of going northbound coming westbound on Vanderbilt Beach Road. Pay attention to that intersection that's on the right. This is Oaks Boulevard. Our goal was to design a lane that would be as parallel as possible to the interstate without interfering with the design of the interstate itself. In this other video, the perspective of driving southbound and taking an exit is illustrated. In this one, an auxiliary road is needed to give drivers enough distance to slow down. As it can be seen, there are some homes that will get in the way of designing a right turning lane. More on that in a bit. If you were paying attention to the perspective of going northbound, you saw that Oaks Boulevard was really close to our desired entrance ramp. Leaving this untouched would increase the likelihood of accident due to drivers entering the interstate and those trying to exit Oaks Boulevard. As a result, we needed a way to divert these drivers, and in this video, we can see in the yellow shading that there is an empty parcel that can be acquired to construct a road for those trying to exit out of this area. In order to allow drivers sufficient distance, an auxiliary road must be constructed. According to AASHTO's specification, an auxiliary road must have a minimum distance of 1,500 feet. As it can be seen, the length of the exit ramp going south before getting to the right turning lane is approximately 1,900 feet. Also, to give drivers sufficient distance to catch up with the flow of traffic, the entrance lane going northbound is designed to be approximately 2,000 feet. The same can be seen with the lower quadrant, where both the entrance and exit ramps have a length of approximately 1,800 feet. Additionally, the road that must be constructed to divert traffic on Oaks Boulevard will have a length of 800 feet. For all lanes within the entrance and exit ramps, they will have a width of 12 feet and a shoulder of 4 feet, as per FDOT specifications. The length of the exit and entrance were determined with the help of these two figures. Adding more to the previous slide, to be able to determine the amount of distance that is needed to come to a safe stop, the stop inside distance was checked by using Table 3.1 and 3.2 from the transportation textbooks and FDOT specification. The stop inside distance for a speed of 70 miles per hour was determined to be 730 feet. As we can tell, we have satisfied this criteria. Also, the length of the auxiliary lane and exit ramp was due to anticipating a huge backup. The length will allow sufficient room for existing traffic to wait in the lane due to issues such as an accident without impacting the flow of traffic on the interstate. Also, with the flow of traffic that is going on Vanderbilt, the addition of traffic lights needed to allow left turn traffic to move. The addition of lights allowing left turn movement is known as a protected movement, which is a movement that has the right of way and does not need to yield to traffic or pedestrian when the light is green.
Since the ramps will be very close to the housing communities, residents will experience an increased level of noise being produced from the traffic of cars exiting off the interstate. To help reduce the additional noise level, sound barriers will be put in place alongside the interstate and will run as far as needs to cover the length for the surrounding communities. The sound walls will be placed in the northwest and southwest quadrant of the interstate, as they are the most vulnerable areas to the additional noise level. For the sound barrier walls to be effective according to FDOT standards, the walls must reduce 5 decibels and must be at a sufficient height that will block the receiver from the view of the interstate. Once the 5 decibel requirement is met, the height of the walls may be increased by 1 meter and can expect to at least reduce sound level of 1.5 decibel per meter increase. There is one restriction to the design of these walls, and that is to ensure that the walls are not to be designed over 22 feet. Also, the walls must be approved by the appropriate public officials to ensure that the aesthetics of the wall is met to their standards of blending into their community. In the southwest quadrant of Interstate 75, sound barrier walls can already be seen. Therefore, to simplify the design of the height of the new wall, it will remain at the same height and be modeled to the same dimensions so that they will connect to the existing, and therefore the new walls will just be added to where there are currently none at this time.
A transportation project of this magnitude means that several land properties and homes will be affected by construction and maintenance services. Due to the design exit ramp coming from southbound I-75 to Vanderbilt Road, the team needs to relocate a total of 5 houses located near Wilshire Lakes Boulevard at Stone's Throw Court. As presented in the snapshot captured by Google Earth, these houses would interfere with the construction of the exit ramp, therefore enabling the team to offer compensation to these residents to relocate and leave their homes. Using Collier County property appraiser services, the team was able to determine the cost value of the houses deemed for relocation. As presented in the table, a report of each address and its assessed value is displayed, totaling the evaluation cost at approximately $1,950,000. It must be noted, however, that inconvenience fees and lawyer charges are not included, thus enumerating the total relocation evaluation to over $2 million for the construction costs of the southbound exit ramp from I-75. Once the team determined the assessment costs for the properties needed to be relocated, the next step was to perform a cost estimate for the entire construction project of the traditional diamond design. When constructing projects of this magnitude, it is extremely important for all involved parties to be on board and on the same page. Effective communication with the public, city officials, and state administrators are essential to reduce time conflicts or any complications relating to the construction of the project. As you can see, the team accounted for all pre-planning, design, development, materials, and road control phases to determine the total estimated project cost. Using the Florida Department of Transportation item average unit cost, the team constructed an engineer's estimate summarizing roadway and structure work required for the overall design project. Using the full AutoCAD design and Google Earth distance features, the team prepared an estimate of probable construction costs based on lengths and distances of the design roadways and ramp. Per the scope of work needed to be performed, the team constructed a table as presented. Using the average unit cost list document provided by FDOT, the item description along with the item number, unit, quantity, and total cost was recorded for each work item. Roadway work item services such as mobilization, maintenance of traffic, barrier work, sign zones, clearing and grubbing, excavation, embankment, painted pivot markings, etc. were required for the scope of this project. Structure services such as modification of existing drainage structures, reinforced steel on retaining walls, and foundation for sound barrier walls were all included in the total estimate. A final submittal of $25,198,486.35 was assessed by the team for overall construction services total cost.
So moving forward into the future, the goal is to have the design to be fully upgradable so that at any moment where the volume of Naples begins to increase more than the design can handle, or if the design needs to be revamped, it can be fully upgradable to handle the brand new volumes that will come about in the next few years. We're looking to convert the conventional diamond into a diverging diamond. The main idea behind this is to reduce the amount of left turn accidents. Through our studies, we found that this has been the major type of accident that can occur, and the diverging diamond is one of the simplest upgradable with our design to be implemented when the volume gets too high, and we can help mitigate and reduce all those left turn accidents, improving the safety of that intersection. And of course, the accidents is the number one goal, but the flow of traffic will be much smoother once we get to this diverging diamond. It will cause less congestion, and there will be less red time, or there would be less time that the drivers have to sit at a red light at the intersection for turning or going forward or what it may be. It will actually flow very smoothly and be a continuous streamline of traffic. Our mentors for this I-75 and Vanderbilt project was Julio F. Ordonez. He's a civil engineer and a principal project manager over at the Collier County Transportation Division. He was the initial starting point for us. He was able to demonstrate and help us see the entire site. We were able to walk the site with him, and we also had two employees from Jacobs Engineering. That's Bill Grammer. He is the vice president of transportation there, and Nick DeCiccio. He is a transportation engineer at Jacobs. And so we spent most of the time working at Jacobs Engineering with Nick and Bill, and they were extremely helpful towards us in providing us the necessary resources that an engineer would have and would go through when designing something like this interchange. They were challenging to us, promoted us to think creatively, and really helped us see the big picture and then break it down into smaller pieces. A lot of new concepts that were foreign to the team have now really kind of set into our minds, and we've gained a better understanding of the process of design from 0% all the way down to 50% design or 30% design, 60% design, 90% design, and now presenting to you the 100% design.
Accelerator Engineering Design would like to thank our mentors, Jacobs Engineering staff, Professor Badir, Collier County for giving us the opportunity to grow as future engineers.